Hello guys and welcome back. So let's take a look at how we can fix the distortion of the iris. Okay, actually not the distortion, the stretching of the pupil. I think it's actually pretty important that we are able to control the size of the pupil because that's going to be something needed in the animation, right? So we need that data. We need to be able to control it anyways. So here we're going to try to also use some mathematic trick to make that happen. Right, so one thing I wanted to do is again, you can see that's what we're having, right? So what I wanted to do is bring this guy back to here again. That's the pivot. Uh, so that's 0, 0. I want the 0, 0 to be in the center. If that's in the center, it's really easy to know if I want to stretch things up and down, it's just going to be based on their coordinate. Okay. So, and after my job, I will add the 0.5 back, basically. So I'm going to do subtract. And again, I'm going to subtract 0.5. Or I probably don't need to add and subtract again. Right, we can basically omit those two together. But just for the purpose of it, because that's one thing we're doing, right? And that's another thing. So I think it's better to differentiate. So we subtract by 0.5, right? We got again the actual pivot is over here now, the 0, 0, 0. Okay, so that's going to be used to, again, I'm going to try to calculate or to have a value to control how much I want to dilate the center part or shrink it. Okay. For that particular reason, I need to actually get the direction for every individual point. What's the unit vector from the center to there? And that's going to be a normalize node. Okay. After I do normalize, you can see it's more solid. Okay, because for every point now in this plane, their coordinate is going to be some value that is basically a unit vector from the center pointing to them. Okay, no matter how far away they are, if you draw a line from center to any point, every point on that line will have the same value, which is going to be the unit vector going across the direction of that line. So that's one thing. We're trying to get that direction, and we remap the length and multiply it back. Okay. So one thing I do wanted to make sure that I actually change is that this is from 0 to 1, but this distance is actually just 0.5. So I have to multiply that by 0.5 so that I'm only covering the U1, V1 space, if that makes sense. Okay, and then I need to calculate the length that I would want to change for everything here in the center so that the pupil can be dilated or shrinked. To do that, I need to get their original length first. So that's going to be vector length. Take a look at what we're having here. This is going to be basically the length of the vector of their coordinate. And because 0, 0 is the center, the length of their coordinate is basically the length they are from the center. Okay, the distance they are from the center. Okay, this length is going to be the radius of the circular shape they're going through. Okay, let me multiply that by 2 so that I can convert radius to diameter. Okay, so that's going to be the entire diameter of that circular shape that point it goes through. Okay. All right. And then I want to reverse that. So this is going to be O and click. Okay. And let's take a look at what we're having here. Okay. We're basically having something like this. Okay. So this is going to be basically, we're trying to read anything that is from 0 to unit 1, right? And flip that. This is going to be the gradient from the center to the edge. The center is going to be 1, the edge will be 0. The edge is going to be the very edge of the pupil texture we're reading. Okay. Right, in that particular case, I'm going to try to multiply that value, okay, by a scalar value as parameter, and this one we're going to be the pupil scale. If I don't multiply it by pupil scale, let me change that to 1 actually. That means we're not changing it. Okay, we use this guy and we multiply this guy on top, or we're actually, let's do lerping. So this is going to be from 0 to 1 all the way, right? From 0 to 1. This is going to be actually, for every point, it's going to be from center to the very edge here. A unit circle here. Everyone is having that vector. And then we lerp that with 0, 0. And the lerping will be, if we just use the original length times 2, actually not timing 2, just the length, or timing 2. So basically this should give us the original result. Let's take a look at that. Oh, actually we have to do a add to add that 0.5 back. Let's wait for it to compile. You know what, I think we should use this one instead. Not there. It is subtract 0.5, we get that, multiplied by 2. So that goes to there. Oh, actually, I forgot to, if we just flip that, and then that goes to there. Actually, we have to connect that. So basically, I'm trying to explain what we're trying to do here. Yeah, that's the original result, right? So that's what we're getting before we do all these calculations. Okay, so we have 2 branches. Right? After the subtraction by 0.5, we branched out 2 branches, and we lerped them with that. So this branch is the direction of the point. It's just a direction. All the length is going to be 0.5. This one is their length we calculate, right? So we multiply the length by the direction again, and we got the original coordinate. So that's not changing. But here, if we multiply a pupil scale, then we're remapping that so that it's gonna be something bigger or smaller, and that effect will be much more in the center and lesser on the edge, because you can see the 1 minus x, 1 minus this value is going to be dark or black here. So you multiply it with anything, it's going to be black. So that's not going to map or change the center at all. It's going to change the, it's not going to change the edge anymore. Even you multiply it by pupil, but it's going to change the center. So we're going to remap the value in the center more than the edge, and we're going to make the center bigger or smaller by doing the pupil scale. Okay, that's the idea here. So again, we branch out the direction and the length. We remap the length so that we can make the center part to be longer or shorter by multiplying it by pupil scale. We multiply the remapped length to the original direction. We got a new coordinate that's going to make the center bigger or smaller, but not the edge. It's going to gradually move the center more or stretch the center more, and not the edge at all. Okay. All right. So I hope that's understandable. So here, back here to the pupil scale, then we can change the pupil scale to 0.7. And you can see, let's wait for it to calculate. See, the pupil is already getting really small. So maybe I can try to change that to 0.8. Okay, you can see now how small the pupil is compared to before. So basically, again, we're remapping the pupil. All right, cool. Now we can also visualize that on the spherical shape, because we were assuming that it's going to be a spherical shape. So this is going to be a little bit more accurate, right? You can see from this particular angle, you can feel like we're seeing something behind, something inside. Okay, how cool is that? So after this, we're gonna try to add our eye white texture backs to replace those guys on the outside of that. So that's going to be something we can do in the next video. Okay, so let's move on to that in the next video.